Once a faulty regulator has been identified as the problem, the regulator can be replaced. The job that you will see is intended as an example. The actual steps performed during a changeout will depend on your company procedures covering the job. Company procedures are generally based on the equipment, safety requirements, and years of operating experience with your specific system. The basic tasks that are involved in changing out a pole-top voltage regulator are similar to those used for changing out other equipment. They include a tailgate session and electrically and physically isolating and replacing the old regulator, then connecting and energizing the new regulator. Let's join the crew at the job site and see how these tasks are performed on this job. Once the trucks are parked and the area has been safely marked off, the crew holds a tailgate session. During the tailgate, the steps involved in doing the job and specific safety considerations are discussed. In addition, crew member job assignments are made so that each person is aware of his responsibilities during the changeout, as well as those of other crew members. The replacement voltage regulator and control equipment are visually inspected to verify their proper size and type. They're also checked for any damage that might have occurred during shipping and handling. Since the control box and cable to the regulator are permanently attached to the old unit, they will be replaced at the same time. The new control cable and control box are inspected for any defects or damage. Next, the lineman notifies the proper authorities that the regulators will have to be bypassed so the defective regulator can be replaced. Bypassing the regulators should keep the voltage balanced on the feeder. Each of the 3 voltage regulators is located on a separate utility pole. Beginning with the 2 good voltage regulators, each regulator is manually zeroed so that there is no difference in potential between the 2 sides of the phase. To do this, the control switch in the control box is used to move each regulator mechanism 1 step at a time until it is in the neutral position. Once the mechanism is in the neutral position, the bypass switch for that regulator can be closed. When the crewman tries to put the 3rd voltage regulator in the neutral position, the controls do not respond. The regulator is stuck in its full boost position. Since there is a difference in potential between the 2 sides of this regulator, it would be dangerous to attempt to close the bypass switch. In this case, it is decided that the best way to bypass the regulator is to have the load dropped on the feeder, bypass the regulator while the line is de-energized, and then re-energize the feeder. The load dispatcher is contacted and arrangements are made to have the feeder dropped. A stethoscope will be used to verify that the feeder is de-energized. A crew member tests the stethoscope on a known voltage source to make sure that it is operating properly. Once the dispatcher confirms that the feeder is de-energized, the lineman tests the phase with the stethoscope to verify that the line is dead. The stethoscope is then rechecked to make sure that it is still working properly. Now the lineman can close the bypass switch safely. Once the regulator is bypassed, he opens the 2 disconnect switches so that the regulator will remain de-energized and electrically isolated. Then the load dispatcher is contacted again, and the feeder is re-energized. Now the regulator can be physically isolated so that it can be rigged to be removed. Before the lineman disconnects the jumpers, he marks each one to indicate load or line. The lineman disconnects the jumpers from the 2 bushings to the voltage regulator and the ground bushing. After all 3 jumpers are removed, the other primary equipment is covered to make the work area safe. Once the work area is safe, the lineman continues to disconnect the regulator from the system by removing the case ground. Finally, a crew member disconnects the control box from the pole, and the box and cable are fed up to the lineman and secured to the tank of the regulator. Now that all of the physical connections to the system are gone, the regulator can be rigged so that it can be removed. The boom of the derrick is maneuvered into position, and its line is attached to the lifting lugs of the regulator with a sling. A tag line is attached to the tank of the regulator and run to a crewman on the ground. Then a test strain is taken on the regulator to test the rigging. Once they're satisfied with the rigging, the bolts holding the unit to the pole are loosened, and the unit is lifted free of the pole. As the regulator is lowered, a crewman uses the tag line to stabilize the regulator and guide it around obstacles. After the old regulator is on the ground, the rigging can be removed and attached to the replacement voltage regulator. Then the new unit can be lifted into position on the pole. Once the new regulator is bolted into place, it can be physically connected to the system. The lineman unwinds the control cable and lowers the box and cable to their position on the pole, where another crewman secures them. The lineman cleans the end of the wire attached to the pole ground and makes the connection to the tank or case ground of the regulator. The end of each jumper is cleaned and attached to its proper bushing on the regulator. Finally, the rubber gear is removed from the rest of the primary equipment and sent down to the ground. Now that the physical connections have been made, the regulator can be energized and tested. This regulator has a built-in transformer to provide secondary control power. Other regulators may be powered from an outside source and may be tested differently. The disconnect switch on the line side of the regulator is closed. This energizes the regulator and provides power to the step-down transformer inside the tank, which allows the controls to be operated. However, the bypass switch remains closed, keeping the regulator bypassed. If the regulator is not in the neutral position, the control switch in the control box is operated until the regulator mechanism has moved into the neutral position. Remember, this regulator is preset to raise or lower the voltage 5% instead of a full 10%. To test the mechanism of the regulator, this crew will move the control switch to the lower position, and they will make sure that the regulator moves 8 steps to its maximum lower position. Then the crewman moves the transfer switch in the control box to the raise position, and the steps are visually confirmed with the pointer position on the dial. Then the mechanism is moved back to neutral and the drag hands are reset. The bandwidth is set and any testing, depending on the requirements of the manufacturer and the company, is done. Before the unit is put back online, the crew verifies that the control mechanism is in neutral. The control switch is in the off position, and the main switch in the control box is turned off. This prevents the voltage regulator from operating while the unit is being put back online. If the regulator is in any position other than neutral, it may cause a short circuit, equipment damage, and personal injury. The disconnect switch on the load side of the regulator is closed and the bypass switch is opened so that the voltage regulator is carrying the full load. When the crew is satisfied that the regulator is operating properly, the control box is re-energized and the control switch is turned to its automatic position. The regulator is now back online. The regulators on the other 2 phases are also reset and returned to service. And finally, the proper authorities are notified that the job is complete.